not really.
You should. Yeah,
Okay. We're going to examine a special kind of rational function today called an inverse variation. Okay. So yesterday we introduced rational functions. We looked at their graphs, and we said that a rational function is a function where we have an x in the denominator. Where we have y equals something divided by x is where we start. And that's kind of our focus for the entire chapter 12 here. Okay. Today we're going to compare and contrast two special kinds of equations. The first one's a review. It's called a direct variation. You may remember direct variation from way back in like September or October, back in first trimester, like back way early on in this course. And direct variation had the following format. They were in this form. Right? And we called A the constant of variation. The reason they were called direct variation is because they vary directly. Or as x gets bigger, so does y. If you made a table of values by picking any old A you want, as x continues to increase, then y continues to increase. They vary directly with each other. Okay? We're going to look at another kind of special variation equation that's more of that's in the rational form, called an inverse variation. And they have this following format. Y equals A over x, where again, A is the constant of variation. These are called inverse variations because as x gets bigger, y gets smaller. And you can kind of see that, you can demonstrate that for yourself if you picked like any A, pick an easy one. How about we look at our friend, the parent function, y equals 1 over x. That's a specific example of this. And if we made, again, a table of values, we can see that as x gets bigger, y gets smaller. And if you want to prove those in decimals, maybe it's a little bit easier to see in decimals. As x gets bigger, y gets smaller. And conversely, as x gets smaller, y gets bigger. They vary inversely. I'm going to write I'm going to rewrite this equation so there's not a fraction. And the reason I'm going to do that is because of this other form of this inverse variation equation is nice because it's going to help you figure out what this constant is if you knew what an x and a y were. So can anyone recall how do I rewrite an equation so that I can eliminate this denominator? I don't want this fraction anymore. I can multiply, to eliminate a fraction, I can multiply both sides by the denominator. So if I multiply the right side by the denominator, they cancel, and the only thing left is what was on top. So if I multiply this by x, then I get A over x times x is just what's on top. And then that means whatever I do to the right, I better do to the left. So I'm going to multiply y by x. This is another form. This is saying that you multiply x and y is always constant or the same. This is a pretty important feature of inverse variation equations. And we're going to use that a little bit in just a little bit. Okay. This is our form of the equation. This is the one we're going to use most often. But this can have its uses when we're trying to find what A is, or when we're trying to kind of understand if a relationship is inverse variation. So our first bit here is we're going to just look at some equations and decide what sort of relationship do they have. Are they direct variation? Are they inverse? Or are they just none of these? So we'll start with this first four. So tell whether this represents direct variation, inverse variation, or neither. So our first one, y equals 2 over x. Is this direct variation, inverse variation, or neither? So certainly inverse. It's inverse variation because it's y equals something divided by x. Certainly inverse. Okay, let's maybe kick it up a little bit. How about 4y equals 3x? Is this going to be inverse, direct, or neither? Or neither, or neither? I think it's going to be direct. You can show that it's direct by getting it into y equals form. So I could divide both sides by 4. And you get y equals 3x over 4. The key here is that you have x in the numerator, and it's just multiplied by something. You could even go so far as to say 3/4 x, or 3x over 4 is the same as 3/4 times x if you were really wanted to rearrange it. In either case, you get y, you have an x, and just something multiplied to x. This is direct variation. Our third one. Is this going to be direct, inverse, or neither? Well, just like these two, let's try to rewrite this so it's y equals. So this is, I like to do the following. I like to add y to both sides. And you get 5x equals 3 plus y. Get the y by itself, so subtract 3. Now it's in y equals. Is this either one of those two forms? Y or y not? Okay, if you're going to tell me neither, you better explain to me why it's neither one of those. Dana, what's going on here? Well, we know what y is. Y is 5x minus 3. What's wrong? Why? If you're telling me it's neither, there's a reason why it's neither. It's because there's a subtract anything here. And neither of these have a subtraction or an addition in it. These have just a y and an x with either something multiplied or divided. There's no adding or subtracting. If this has it, then this is certainly a reason for it to be neither. I'd like to do the last one with you guys, and then I want you to do the bottom 3 on your own. So xy equals 1/2. Is this going to be direct, inverse, or neither? Why inverse? Because it says so in the notes. Yeah, it looks like one of the forms of inverse is x times y equals something. X times y equals something. Is another way to rewrite an inverse variation. So this is certainly an inverse variation. So look at the bottom 3 here on your own, and let's try to find those and jot them down on your paper. Make a decision, and be prepared for me to ask you why you chose those. All right, most of you got the first one. It's almost identical to the previous. This is inverse. The middle one. See, some of you, I saw about half of you got the correct answer, and half of those people got it the wrong way. The correct way to come up with a solution would be eliminate this fraction. So multiply both sides by the denominator, which is y. X equals 2y. Divide by 2 to get y by itself. So y equals x over 2. So now we have to make a decision. Is this inverse or direct? Well, where is x? Is x in the numerator or the denominator? Denominator is below. So this is above. This is in the numerator. Which one of these has x in the numerator?
Inverse.
If it was inverse, x would be in the denominator, which is below. Is x below the fraction bar here? No. It's above. If you really want to get technical, you could say x is the same as 1 times x. 1 times x over 2 is the same as 1 over 2 times x. This is certainly a direct variation. If you said this is direct variation because I used inverse once, this one is neither, so the middle one has to be whatever the other one is, well, good luck. Probably on your test just put multiples of the same. So that line of thought is not the best route to go. Okay, in this example, to get through the notes today, it worked. It probably won't work in the future. Is it clear why this is neither? Or did anyone... It didn't look like many people thought it was one of the two.
Is it just a positive addition or subtraction from the start? Is that just like neither right away?
I wouldn't go there right away. Once you get into y equals form, that's when you want to make a call. Because I could be mean and say something like if I said 5 minus this, or plus it or whatever, I could subtract the 5s, and now there isn't any of what's making it kind of a bad thing. Okay, I didn't have that though. So to show this neither, I want to get y by itself. So like I did before, I'll add y to both sides. You get 3x equals when it's all said and done, when y is just equal to itself, there's a minus or a plus. So there's our neither giveaway. Okay. If two variables vary inversely, that means they follow the inverse variation pattern, which means that they fit, x and y have to fit into this pattern. What's nice is if you need to figure out the equation, the only thing it's missing is whatever this value of a is. That's where this guy comes in handy. This format of the equation can help us find a very quickly. Because if I tell you what an x and its partner y is, you can calculate a pretty quick because we know that x times y is just a. Or in this case, -6 times 2 is whatever a is.
Wait, you said inverse. Wait, what do you have to use an inverse equation where it's like y?
This is one of the variations. This is a way to rewrite it. Right? A in this case is -12. So the equation in the standard form here, y equals something over x. What's the something that goes on top?
A.
A is -12, so since a goes on top, we'll put its value. There's your equation for this inverse variation.
Would you fill out everything else too? If you know a y and x.
So an equation has a y and an x so that you could calculate other values.
What's the point of writing the equation when you can know the whole thing?
Well, because, for example, I want to this time change what x is. So what y goes with x when x is 8. If you have an equation like this, now I can calculate other values of y. And what does -12 over 8 simplify to? What's a number that goes into both 12 and 8? 4 is the largest. 2 does, but 4 is the largest. So 4 goes into both of them. 4 goes into -12 3 times. It goes into 8 twice. So when x is 8, y is -3 over 2. Let's calculate this guy on your own. Your equation should be, let's see, x times y equals a, -2 times 12.
So you do 24 divided by 8.
A is 24, therefore your equation is y equals -24 over x. When x is -3, you say y is equal to -24 over -3 equals +8. We can use this same idea to tell whether some data represents inverse variation. If a function is inversely varies, that means the product of x and y is always the same. So if you're to multiply the x's and y's together, you should get the same thing for your entire set of data. So we'll check this data to see if we do. -5 times -1 over 6 is 8. -2 times -4 is 8. 2 times 4 is 8. 10 times 0.8 is 8. Half of 16 is 8. When we multiplied x and y, we get the same constant. Therefore, this is, yes, inverse variation. And what do you think the equation for this inverse variation function would be?
Y equals 8 over.
Jacob, that was a stroke of genius. Y equals 8 over x. We play the same game over here. Let's see. Negative 2 times negative 5 is 10. Negative 4 times positive 2.5 is negative 10. You might as well stop right there. You can keep going if you want. But unfortunately, those two things are different. A is not always the same. This is not inverse variation. Nothing more to do. Okay. I'm going to leave the story problem. We'll try to talk about this next time, but I'm done for now.